Okay, I just realized how incredibly rude I was, and I told you what to do in the last video, but I didn't really tell you or give you any examples. So let's do one. 5, 10, 15, on and on and on forever. Is this geometric? Go ahead and try that really quickly. Pause. Okay, play. Hopefully you said no, because 10 divided by 5 equals 2, and 15 divided by 10, well, it does not equal 2, it's 1.5. So no common ratio. This is not geometric. In fact, what is this? It goes up by 5, and then it goes up by 5, and it goes up by 5. This one is actually arithmetic. So the common difference is 5. No common ratio. Let's try another one. What about this one? 10, 20, 40, on and on and on and on forever. Is this geometric? If so, what's the common ratio? Pause. Play. This one is geometric. 20 divided by 10 is 2. 40 divided by 20 is 2. So this is geometric, and the common ratio is 2. So let's expand on that and find the 10th term in this sequence. Hopefully you recall that for geometric, a sub n equals a1 times r to the n minus 1. So if I want to know the 10th term, I take the first term, multiply it by my common ratio, risen to the n minus 1 power. So 2 to the 9th power is 512 times 10. My 10th term in this sequence is 5,120. Awesome. Let's do another one. What if I've got this one? This is a good one. 18, negative 6, 2, negative 2/3, and it just keeps going on and on and on forever. Is this geometric? If so, what's the common ratio? Pause. Okay, play. Hopefully you are actually pausing and playing and trying to do this on your own, because if not, I will feel sad. Negative 6 divided by 18. That equals negative 1/3. What about 2 divided by negative 6? Well, that's also negative 1/3. Well, what about negative 2/3 divided by 2? Ooh, that's a kind of a tough one, but you bet it, yeah, it's negative 1/3. So our common ratio is negative 1/3. And so if our common ratio is negative 1/3, not divided by 3. Common ratio in this case is not divide by negative 3. Get out of that habit right now. Our ratio is multiplying by negative 1/3. And so let's put it into our formula. 10th term. The amount of the 10th term in this sequence is going to be our first term multiplied by our common ratio. Now you're going to want to put parentheses around that to the 9th power. Where'd that 9 come from? N minus 1 is 9. So let's do this. Negative 1/3 to the 9th power is a super long number, and you times it by 18, and I'm just going to go ahead and write this out. Negative 9.14 times 10 to the negative 4th power. So see how it's super, super small, but it'll never get to 0. It'll approach it, but it'll never get there. All right, so that's enough sequences. Let's try a geometric mean problem real quick. So let's say we've got 3 and then blank and then 3/4. If this is geometric, and it tells us it is geometric, we need to find out this missing term by doing the geometric mean. So we're going to do 3 times 3/4 and take the square root of that. And that's going to give us plus or minus 1.5. Again, if you don't understand why that needs to be plus or minus, you need to leave a comment, and maybe I'll answer it there, or maybe someone else in the world will answer it. Fantastic. Let's move on to series. So if you have a geometric series, I've already told you there's a couple different ones. If you have a finite, you're going to use this formula. If you have an infinite that converges, you'll use this formula. If it's an infinite and it diverges, well, then you're SOL. No sum. So let's do a quick example of each, and then, like I said, you could always use sigma notation and the calculator, which is my favorite way to do it because it's much quicker. So let's get us a series here. This one is infinite and diverging, so we'll go to here. 3 plus 1 plus 1/3, and it goes on and on and on forever. You can see that it has a common ratio of multiplying by 1/3. Just throwing that out there, you should be able to see that. Our common ratio is 1/3. We're multiplying by 1/3. So let's plug this in here. The sum of this is going to equal our first term divided by 1 minus our common ratio. So that's going to equal 3 over 2/3, and hopefully you can figure out how to work this fraction on your own. If not, I can show you in class, but 3 divided by 2/3 is going to equal 4.5. That's the partial sum. We call that a partial sum because it's not really true because it goes on forever, so in theory it should keep going. It should keep getting bigger, but we're really converging on this number 4.5. That's our partial sum. Now let's look at a finite geometric series, one that has an end. So something like this in purple. 2 plus 4 plus 8, and we say it goes to 16. So 1, 2, 3, 4. It has those 4 terms. It comes to an end. It's over. It's just those 4 terms. So let's plug all this in there. First, find the common ratio. It looks like it's 2. 4 divided by 2 is 2. 8 divided by 4 is 2. Great. We know our common ratio. So the sum of these 4 terms is equal to the first term times 1 minus 2 to the 4th power all over 1 minus 2. So let's do these in parts. 2 to the 4th power is 16. 1 minus 16 is negative 15. Times 2 is negative 30. Divided by negative 1 is 30. And if you double check with your calculator, 2 plus 4 plus 8 plus 16 is in fact 30. So if you have any questions, leave a comment. Maybe I'll answer it. Goodbye.